Blast furnace. At the end of this module, you will be able to explain the process of extraction of iron, list and describe the various parts of a blast furnace. Did you know the world's first ever metal bridge to be built was the Iron Bridge? It spans the River Severn in Shropshire, England. And that the Eiffel Tower in Paris is made of more than 18,000 pieces of iron? Every day we come across innumerable objects from nails to skyscrapers to bridges which are made of iron or have iron as an essential component. Why is iron the most widely used metal? The main reason is that it is strong and relatively inexpensive. Iron is the most abundant metal found in the Earth's crust. As it is a reactive element, it does not exist as a metal in nature but is found in chemical combinations with other elements such as oxygen, sulfur, and carbon in the form of minerals like hematite, magnetite, goethite, limonite, and others. Hematite and magnetite are the main ores of iron. Ores are obtained from the earth by mining and iron is extracted from them. Have you ever wondered how iron is extracted from its ore? Iron is extracted from its ores in a blast furnace. What is a blast furnace? How is iron extracted using a blast furnace? Come, let us find out. Let us take a look at the different parts of a blast furnace and study their functions. The blast furnace is a huge furnace used to extract metals from their compounds using a suitable reducing agent. It is a tall chimney-like structure about 30 to 40 meters tall and about 10 meters wide at the base. It is narrow at the top, increasing in diameter downward but narrowing again near the bottom. The bottom portion is called the hearth. It is lined with fire-resistant bricks. At the top of the furnace is a double cup and cone arrangement. This arrangement is used for the introduction of the charge, which is a mixture of coke, concentrated iron ore, and limestone. The furnace has three outlets, an exhaust gas outlet at the top for the hot waste gases and two outlets at the base for discharging molten metal and slag. The gas discharged from the gas outlet is passed through a dust catcher to remove suspended particles and then fed to the stoves to heat the air that is blown into the furnace. At the bottom of the furnace, there are two nozzles called tuyères, through which hot air is blown into the furnace. This process is called blasting, and that is why the furnace is known as a blast furnace. Extraction of iron from blast furnace. At the end of this module, you will be able to describe the working of a blast furnace. Let us now find out how iron is extracted from its ore in the blast furnace. Before the ore can go into the furnace, it has to undergo certain preliminary treatment like concentration or dressing and roasting or calcination. Iron ore mined from the Earth's crust contains impurities such as sand, rocky materials, limestone, etc. The impurities are collectively known as gangue. The gangue must be removed before the metal can be extracted. The process by which impurities are removed from the ores is known as concentration or enrichment. To begin with, the ore is crushed into small pieces in a crusher. The crushed ore is then powdered in a grinder or pulverizer. The powdered ore is then washed in a current of water to remove impurities. The heavier ore particles settle down while the lighter impurities are washed away with the water. The concentrated ore is then subjected to a process known as calcination. The ore is heated strongly in the presence of air in a reverberatory furnace. Besides converting the non-oxide compounds in the ore to the oxide, roasting helps in removing moisture and organic matter. Impurities such as carbon and sulfur are converted to their volatile oxides which escape. In addition, ferrous oxide present in the ore is oxidized to ferric oxide. Let us now see how iron is extracted from the roasted iron ore. The process of extraction of iron from its ore is known as smelting. The roasted ore is mixed with coke and limestone. What roles do coke and limestone play? Coke functions as the fuel, at the same time gets converted to carbon monoxide required for the reduction of the ore. The limestone acts as a flux. A flux is a chemical substance which combines with impurities and forms a fusible slag. The charge is brought by trolleys or skip cars over a conveyor system and introduced into the blast furnace through the cup and cone arrangement. Simultaneously, a blast of hot air is blown into the furnace through the tuyères at the base of the furnace. The hot air causes the coke in the lower regions of the furnace to burn, producing carbon dioxide and a large amount of heat. This region is called the zone of combustion, as the combustion of coke takes place here. The temperature in this region reaches around 2000 degrees Celsius. The carbon dioxide rises and reacts with the unburned coke to form carbon monoxide. At the same time, the heat causes the limestone present in the charge to decompose and form quicklime and carbon dioxide. The reduction of carbon dioxide and the decomposition of limestone are endothermic reactions. Owing to this, the temperature of this region falls to about 1000 degrees Celsius. Calcium oxide or quicklime fuses with impurities such as silicon dioxide to form liquid calcium silicate or molten slag. The slag flows to the bottom of the furnace and floats on top of the molten iron. This is tapped periodically into ladles for disposal. Since molten slag is produced in this middle region, this region is called the zone of fusion. The temperature of the upper region of the furnace is around 400 to 700 degrees Celsius. In this region, the descending charge is exposed to the action of carbon monoxide streaming up from the lower part of the blast furnace. Carbon monoxide reduces ferric oxide to iron. The iron so produced is a spongy porous solid. As reduction of iron oxide takes place in this region is called zone of reduction. As the iron descends down through the hotter regions of the furnace, it melts. Lower down the furnace, where the temperature is high, any unreduced core is reduced directly by carbon. The molten iron collects at the bottom of the furnace and is tapped periodically. It is poured into sand molds and allowed to cool and solidify. The iron obtained from a blast furnace is brittle and is called pig iron. Note, the term pig iron comes from the time when the molten iron was fed into molds from a common runner. The whole arrangement looked like a sow suckling its piglets, with the runner being the sow and the molds the piglets. The solid iron ingot removed from the molds were therefore called pigs. The unused carbon monoxide, along with nitrogen from the hot air and carbon dioxide, pass through the outlet at the top and enter the dust catcher, which removes dust and other particulates. The dust-free gaseous mixture is burnt in special burners, and the heat produced is used to heat the air that is blown into the furnace. The processes of addition of charge and removal of molten iron and slag goes on day and night for years. The blast furnace is shut down only when the fire brick gets worn away and needs to be replaced.